Well, here we are at Tinker Air Force Base. We're just east of Oklahoma City, right on I-40. And if you can see, I'm standing in front of an airplane hangar, which makes a lot of sense because I'm at an Air Force base. Well, the subject of our show is behind these doors. I'm not going to tell you what it is yet, but I'll give you a hint. If you've ever driven on I-40, you've noticed at the main gate, there's a bunch of planes on displays, and it's one of those airplanes. It's one of the best looking planes the Air Force has. Well, we're going to meet somebody inside that's going to give us a tour of the airplane, tell us what it's doing here. So I hope you can join us for the next 30 minutes. If you're ready to go, let's go inside. Well, we made it inside, and I'm standing here with a gentleman who will explain what we're doing here and what we're about to see. Why don't you introduce yourself?
I'm Bill Bauman. I'm the 567th AMXS Squadron Director here at Tinker Air Force Base.
And in English, what does that mean?
That means I oversee the maintenance and overhaul and production efforts on the B-1 bomber.
The B-1 bomber. Well, there it is.
Here at Tinker, we do heavy level maintenance of the B-1 bomber. We call it program depot level maintenance. Aircraft come in. We also do major modification efforts, which is what we're looking at behind us.
Okay, so this plane is going through some type of modification.
Right. This is a major block level modification to the B-1 bomber to upgrade its capabilities and also modernize some of the systems on it.
And you say that you also do regular maintenance on these aircraft. What kind of schedules does this type of aircraft go through?
Over across the street, we do program depot level maintenance. It's every 5 years, the aircraft comes in. We do a maintenance overhaul effort where we disassemble the aircraft, we inspect it.
Completely disassemble the thing?
Disassemble to the point that we can do an adequate inspection.
Okay.
And there are components that we replace on a periodic basis. We give it a good inspection, and then we repair those things that we find wrong or that engineering deems necessary for repair at that time.
Well, are we allowed to get inside?
Sure, sure.
Let's head on up the steps. You can lead the way. Okay, Bill, so where are we here? It looks like the cockpit.
We're at the forward crew area of the aircraft. I'm standing in an area where an ejection hatch would sit.
An ejection hatch.
Right.
Are there many bombers that have ejection hatches?
Most fighter type and bomber type aircraft have a ejection seat type egress system in them.
I've heard of that in fighter jets. I just never thought of it in the bomber.
Right. Bombers have them as well.
Okay. And so that's what would come off. That's why you're allowed to stand right there.
I'm standing where the pilot's seat would be right now.
Now this is just completely dismantled.
Right. This aircraft's taken apart as part of a major effort. This is about a 17,500 hour modification. We bring an aircraft in, we defuel it, hangar safe it, and then we tow it from Tinker proper over here across to the MROTC facility on the east side of Douglas. We bring it in here. The hatches and seats are removed for access, along with the panels and all the equipment in this bay. We take out the forward instrument panels, the offensive system officer and defensive system officer seats and consoles, and we remove wiring necessary to facilitate the mod. From that point, we lay in new wiring. We clamp it, string tie it, terminate all the ends. There are over 19,500 connections in this modification. So it's a pretty large level modification. The consoles are modified to accept new equipment, and they're removed from the airplane, taken off for that, and then we put them back in.
Now you mentioned it was about 17,000 man hours. Talk about in terms of days, weeks, months. About how long does it take?
In days, working in a small area with a number of people, it takes us about 218 days to get an airplane from wheels down to wheels up.
Okay, Bill, we are under the aircraft right now. What are we looking at here?
We're in the forwards weapon bay compartment. There's 3 weapons bays on the B-1 bomber: a forward, a mid, and an aft. Right now, the rotary magazine that holds weapons is removed.
Okay.
They take it out before we bring them in here for
Is that,
maintenance.
I'm picturing like a revolver.
It's similar in concept to a revolver. A rotary magazine where you can install multiple different types of weapons.
So that's that center point that I'm seeing.
Right. That's what it rotates on.
Okay.
Rotates around.
So it can have multiple, each bay, or will each
bay
magazine have?
It can have a
different?
variety of weapons in each bay, and a variety of different types and different numbers in each bay.
Now that reminds me, you had told me when I met you that the B-1's mission has kind of changed from when it was first conceived.
The B-1 was originally conceived as a high-altitude, high-speed bomber for penetrating Soviet airspace.
About what year?
In the late 70s, mid to late 70s. It was canceled during the Jimmy Carter administration for budget cutbacks, but it was resurrected by Ronald Reagan in the early 80s. The original concept, the B-1A, was upgraded. This is really a little bit different model of B-1B. They raised the capacity for the weight it could carry, but it slowed the aircraft down a little bit. And it took
So originally it was nuclear weapons.
Originally had a nuclear mission. Today it's a conventional weapon bomber only. Okay, over here, Will, I'd like to show you some of the structural work and repair that we do. Here's a sheet metal modification that's going on. This is Bob Levery.
Hi, Bob. Will Schwab.
Hi there, Will.
And how long have you been working on this program?
7 years.
7 years. And can you tell me what we're looking at over here? You can come around this way, Bob.
Okay, sorry.
Yeah, it's okay.
We're pulling off the skins. When these tires blow, the rubber's been hitting underneath.
Okay.
So we're pulling off the skins and we're beefing it up with intercostals and changing frames because you're not necessarily seeing the frames crack through the skin.
Now I'm looking at a ton of rivets. How do you get those out?
Drill bit. They're all drilled.
You got to re-drill them out.
Every one of them has to be re-drilled.
Okay. And then that's like the bone structure of it.
Yeah.
And that's the skin. What am I looking at over here?
Over here, you're looking at the wings, the root of the wing where it actually sweeps.
Oh, okay. Yeah, I see the little tracks.
So that's all opened up so we can look at the mechanism underneath that sweeps the wing, as well as all the structure, make sure everything is still functioning.
So you're looking under the hood.
I'm looking under the hood.
You got a part of this aircraft you really enjoy working on?
All of it.
Yeah?
Yeah, I don't like the crew compartment. It's too tight.
Yeah. So, Bill, how many people are involved in this overhaul program?
In the overhaul and the modification program together, we have 425 people devoted. That includes your mechanics, electricians, avionics, structural mechanics, planners, schedulers, material people, all those people who support this weapon system while it's here.
Now, this hangar's a pretty good size. How many planes can you fit in here?
We have a capability of putting 4 aircraft in this building at one time.
And how many planes are you typically working on?
And we have about 6 or 7 aircraft in the maintenance part, in the overhaul, and 6 or 7 in the modification part at one time.
Now, I noticed this plane looks a little different. What's going on here?
This aircraft is scheduled to have the outer mold line of paint removed so they can more thoroughly inspect it. These aircraft don't get it on every cycle through, but they get it about every other cycle.
How do you get all that paint off?
It goes to a facility where it's masked and taped, and they use plastic media blast to blast the entire surface of the aircraft to remove the paint. There are many composites on this aircraft, so you can't use a chemical paint removal process.
What's happening with this aircraft?
A major part of the stress is induced in the tail of the aircraft, so this is one of our major depot level tasks. The horizontal surfaces are removed and they are sent back into supply. Okay. They're overhauled here locally at Tinker in a different commodities maintenance group.
I was wondering about that. If you come across a part that maybe it's completely damaged, you need it remanufactured or manufactured, where do you get a part like that?
Well, on a 30-year-old airplane, that's quite a challenge. There are still vendors out there who manufacture some parts for us, Some parts are available, they're known, but we run across things every day that weren't anticipated. We're approaching what was originally the design life of the aircraft, but we're extending that out. We intend on keeping it for another 20 years. So we have to come up with unique ways of repairing these aircraft to get them to that lifetime. Some parts, we take molds of them and we send them over to a commodities maintenance group, and they have manufacturing capability over there where they take raw stock and they make the parts.
It's just such a beautiful aircraft.
Yeah, this is a beautiful aircraft. It's high performance. Even today, it still does the job that we need it to do. Not the original intended mission, but the job that we need it to do.
A lot of us have probably seen Top Gun, and
Right.
you know, they're banking. And why would a bomber need to have swept wings like this?
Well, because of heavy gross weights on the aircraft when they take off and at low speeds, they need that extra wing stuck out there so they can achieve the lift to get the aircraft off the ground. But once they get in flight and they get in high speed configuration, you can't have that drag out there. So those wings swing back into this area, back into the aircraft, so it's a more aerodynamic design that can achieve a little bit higher speed.
And where else are these based?
These are based at 2 locations in the United States today: Dyess Air Force Base in Texas and Ellsworth Air Force Base in South Dakota. There's also a couple of test airplanes at Edwards Air Force Base.
So we don't consider the B-1 being based at Tinker.
No, it strictly comes here for maintenance, modification, and overhaul.
So the air depot,
The air depot.
not air
work
depot, air depot.
the air depot work is done here.
Okay. And that, what does that mean to
What
the
that
civilian?
means to us is this aircraft comes in for maintenance that's above the level that can be provided at a local base. Airmen at the bases maintain the airframe on a daily basis and take care of it and fly it. But it comes in here for those jobs that are over and above their capabilities.
And Tinker, that's kind of what Tinker does.
That's what
We're
Tinker does.
We're a depot.
That's
Air
what
depot.
Tinker does.
So what are we looking at here?
This is one of the components that receives a lot of stress during flight of the aircraft. It's the lower rudder.
And where does it go on
It goes right underneath the tail
Right in
here.
that
It
spot.
controls the yaw, the point in the nose of the airplane.
Oh, okay.
And these because of where they are and the work they do, they get a lot of stress on them, and it causes cracking and corrosion, and the parts fail. So every 5 years when they come in, we take these off and inspect them. We send them off for an overhaul in another facility here on Tinker, not in the aircraft, but they're overhauled here as well.
What is your name?
Charles Neighbor.
What is your role here?
I'm a supervisor over production for the B-1 back shop.
And what is your name?
Daryl Anderson. I'm the squadron director for the 551st Commodities Maintenance Squadron.
551st is, what was that again?
551st Commodities Maintenance.
We have to wear our gear here to protect our ears and our eyes, and it's kind of hard to hear. So what are we looking at here?
Yes, these are lower rudders. They go through the same process. They come off the aircraft, come to us. We completely tear them down. This is a hinge beam. We are doing a mod where we replace those, and we put a brand new one on.
You guys say model. That's a modification. That's okay. I think we're getting the lingo down.
And this is one of those, that's what's happened over time. When the aircraft was originally built, this hinge beam structure is what attaches this to the aircraft, was an aluminum structure.
Okay.
And after so many years of flying, you start seeing cracks and different kinds of wear. And so the modification is we've gone back in with a steel structure to
okay.
replace that. So
And what building are we in?
this is building 9001. This was the former General Motors.
Okay, I remember when we acquired, the city sold it, I believe, to Tinker. Okay, so we're in that building.
Yes. So about 2.5 million square feet of floor space just in this one building that's shared by Commodities, the Commodities Maintenance Group, which we're a part of.
2.5 million. Where were you all before this building was acquired?
We were actually in a number of different buildings across base. So this was an opportunity to consolidate a lot of those functions. Actually, we did this study on whether or not this would be a good thing for the Air Force. We started tracking pieces and parts as they moved. In our prior arrangement, we had parts moving, up to 5 miles, going between different buildings.
Wow.
To get different
Okay, so it
processes
just
done.
brought it all in
Brought
here.
it all in here, and so now it's a very, consolidated effort.
And climate controlled.
Yes,
Working
nice place to
year-round.
work.
Well, it is an amazing building, and I appreciate the time. Thank you so much. And keep up the good work.
Thank you. Happy to have you over here.
Hi, I'm David Herrera. I'm the production support flight chief for the F-101 engine,
And that's in the B1.
the engine that's used in the B-1 bomber. And we're looking at a bearing area that they're building up on this intermediate case.
So you've been working on this. What are you guys doing here?
We're stacking the number 3 bearing assembly on the HPC to the fan frame.
I'm trying to think right now how many people have seen what we're looking at. I mean, this is not something you see on the internet, I don't think, is it?
I would certainly hope not.
Well, that is just fascinating. The inside of a jet engine. And who manufactured this?
This is a GE product.
GE product.
I'm Nathan Pitkovich. I'm in the commodities maintenance group here at Tinker, and we provide the support for the shops, all of the shops out in our maintenance area, to overhaul the equipment as it comes in and to get it back out on the jet as fast as possible.
So whenever I was over in the hangar looking at all the different parts, those are the commodities you would say?
Yes, all of the flight controls, the rudder, the aileron, elevator, all of those things we work here in 9001.
So there's a huge amount of people supporting what they're doing over there before it even gets to that point and back and forth, I would imagine.
Yes, sir.
Now, and one of the things we were talking about is how old the planes are, and I believe you guys have a solution for some of those challenges that they may when they don't have a part.
Yes, sir. Here in the React office, we deal with the part supportability issues which stem from having a lack of information, a lack of drawings. These aircraft that we're working on are 50, 60 years old, and a lot of the information that they had in the past is gone or incomplete.
So what do you do?
So here in our office, we have different ways of collecting that information, whether it's using our laser scanner, or looking at the old drawings and scanning a sample part and kind of combining the two
So you have to recreate it.
in order to reverse engineer it.
Okay, reverse
Yes.
engineering. Okay. So these are old drawings, but they might not be adequate to, or enough information to recreate the.
Yes, sometimes there are missing dimensions, areas that are unclear, and we will actually model it from those drawings and print out a sample part.
So how do you show me the scanning process?
Okay. So this would be a mold that is taken from one of the aircraft outside while they're doing
I'm gonna
maintenance.
come on this side. Do we get a? Okay.
And we will scan this mold in order to create a custom fitting for repair for that aircraft. So this scanner
Oh, wow, look
works
at that.
pretty fast, and we can capture a lot of the data relatively quickly.
And it's recording all those points.
So this is a mesh file that we would get from that scan that we just made.
All that
And-
information from the scan converted into that.
Yes, it's actually just a surface right now, and then in order to have a CAD model from that, we will create a model in an AutoCAD type program
Sharper edges and.
to
okay.
create the actual fitting and the geometries that we need for that part.
Okay.
Once this is created, we can send it over to our 3D printer next to us.
Oh, right here.
And
Look at that.
it will run for a few hours, and a similar part to this would come out of this gypsum powder.
Look at that.
And
Gypsum powder.
Yes, and we can take it out to the aircraft and do a fit test within a matter of hours.
Nate, what am I looking at here? What? This looks like it came out of the cockpit of the B1.
It did. It is right above the pilots in the B1, and our old panels are actually breaking and deteriorating because they've been on the aircraft so long.
Sure.
So here in this office, we're actually trying to reverse engineer some of these panels, and this is one example where we can go straight from the printer to the aircraft and actually install this into the aircraft.
So you don't have to make something after that. That's the
No.
finished product.
Yes, this is
So
the
let's see how those two compare. Okay. So you just scanned this, and the printer printed that.
Yep.
That is fascinating.
Choose the right material for the application and make sure it's going to be strong enough and do what it was originally intended to do.
Holding
And-
gauges and things of that. It's not a
Yes, sir.
huge structural thing.
Yes.
It's oh, that is beautiful.
So this is kind of where 3D printing shines, is being able to take those designs and get them out to the aircraft as fast as possible, and don't have to go through the original way of manufacturing it, which can take some time, have
Sure.
some lead time.
Sure. Well, we've got quite a treat here. We are actually in the cockpit of a B-1. Bill passed us off to someone. Why don't you introduce yourself?
Mike Griffin.
And you are a test pilot, is that correct?
That is correct.
Now, explain to me why we need test pilots on the B-1 program here at Tinker.
Well, so what they do here at Tinker is they tear these jets apart so that we can keep them flying. They do some real invasive maintenance. And when they put them back together, we need to make sure we put the jet in the air and that they put it together right.
So it's like I take my car to the mechanic. We got to run it around the block. That's your job.
Exactly. So they want experienced guys who understand the jet, and we fly it to its extreme parameters, really wring out the jet so that we can give it back to maintenance. They can fix whatever issues. And that way, when we give it back to Dias or Ellsworth, those crews don't have to worry about that. They can focus on their mission, on their training, and they don't have to worry about whether or not the jet's going to be flying right.
You mentioned experience. How long have you been flying the B-1?
I've been in the B-1 since 2006.
And is this a plane you sought after?
It was. This was my first choice out of pilot training. I absolutely love it.
Fantastic. And you've been on missions, so you've got this. Where are some places you've been in the B-1?
So I've deployed 3 times, flown combat sorties over Iraq and Afghanistan mostly, and then various TDYs, England, Spain, that sort of thing.
Now, I don't know a whole lot about planes, but I've seen what looks like steering wheels and sticks. I'm noticing the stick. Can you see the stick in here? Is this common in a bomber?
As far as the B-52, that's what everybody thinks of when they think of a bomber. That's a flight yoke, kind of like your steering wheel you were talking of.
Like in a commercial aircraft we see.
Exactly. And then the B-1, obviously we got the stick, and then the B-2, I believe that one has a flight stick as well.
So this is such a good-looking airplane. It looks like a giant fighter jet. Does it fly like a giant fighter jet?
She sure does. Yeah. She flies like a T-38. She will pretty much give you whatever you ask of it, and she is a blast to fly. She's really designed to be flying with the fighters, and so she's got the speed and the maneuverability to kind of keep up with those guys. We typically, we can fly anywhere from 200 feet above the ground at nearly 700 miles an hour, or up at altitude 20,000 feet at 1.2 Mach. So she's very versatile in where she goes, and as you pointed out, the wings move, so it allows us to fly in a large variety of flight parameters.
Okay. Now this cockpit, you've been flying since 2006? You say, has this changed a lot over the years?
The legacy mod that we're used to flying, that I grew up on from 2006, awesome mod, but it's limited in its capabilities, and this is basically making us ready for the 21st century.
And how many folks are up here?
We got 2 pilots, and then we have 2 weapon system operators in the back, so there's a crew of 4.
The 2 in the rear also pilots?
No, for lack of a better term, they're navigators, but they're a lot more than that.
Yeah.
So they're called weapon system operators. The guy that sits behind you, he's the offensive system operator. He runs the radar, and he's basically the one in charge of all of our bombs.
Okay.
And the guy that sits next to him, who would be behind me, he's our defensive system operator, and he's got an array of sensors and capabilities that allows him to see if we're being looked at, who's looking at us, if we're being shot at, and his job is to help us defend the jets so we get to come home safe.
This doesn't have guns.
No guns, unfortunately. A lot of bombs.
Yeah.
But
now, what about the 2 pilots? Do you have different missions or responsibilities in here, or are you redundant in one sense?
Both.
Okay.
So when we fly our long duration sorties, having 2 pilots allows us to take turns flying the jet, because it takes a lot of energy to fly the jet and just stay on top of everything. I kind of think of it as like an orchestra. You have one guy who's in charge. We call him the aircraft commander. And he's like the conductor. And then you have different elements. You have the co-pilot who's flying the jet. You have the offensive operator who's kind of working the bombs and radar. The defensive guy is kind of defending the jet. And you have the aircraft commander who's kind of sitting here, and he's coordinating all of those guys, as well as talking to outside agencies, talking to other airplanes. And so it becomes kind of a dance, making sure everybody's doing their job. And it works really well in this jet.
A typical mission, are you in this plane a long time, multiple hours?
It really depends on the mission. I've been on missions that were 16, 17 hours. I've been on training sorties. On average, the training sorties around here are 3.5 to 4 hours.
Okay, so 16 hours.
Yeah.
You guys have a galley back there?
Not a galley so much. We have a chemical toilet, and then whatever Food you can bring in a bag.
Well, here we are back in the hangar with Bill and Michael. I guess you weren't with us, so you didn't get to see. We got to go up inside of the cockpit. Michael took us up in there. And then we went over to the supply chain, the old GM plant. What do you call that over there?
Over there, building 9001, it's where our commodities and our propulsion divisions are
Got to
housed.
see all that.
They support the aircraft through overhaul of components and overhaul of engines and direct support of engines.
What kind of people are we talking? I know you said you had about 400 and so.
We have a little over 400, 425. We're supported in the complex maintenance complex alone with numbers approaching 10,000.
Wow, 10,000 people.
And even outside of that, in the Air Force Base, outside of the maintenance complex, we're supported by our System Program Office and our DLA, our Defense Logistics Agency, who support us with material.
So it's just layer upon layer.
It's a vast complex across a 28,000 people population base, even directly supporting us.
This is a small city, or a good-sized city.
It's a good-sized city, sir.
Well, I want to thank you both. Thank you, Michael. I really appreciate that. Thank you, Bill. We've really enjoyed our time today. You know, it's places like Tinker Air Force Base and the important work you do here and programs like the B-1 Overhaul Program and people like Bill and Major Griffin. They come to work every day to ensure that our men and women in uniform have the tools they need to keep us all safe. It's these programs and these wonderful people. They're unique to Oklahoma. They're all part of what makes Oklahoma grand. Oklahoma Grand is a proud partner with TEAM, an interfaith nonprofit organization determined to break cycles of incarceration in Oklahoma. Visit team.org. Oklahoma Baptist University, offering a fully online MBA in Project and Energy Management, International Business and Leadership. Visit okbu.edu/graduate.
And Producers Playhouse. Creative visual communications for Oklahoma since 1997.
For more in-depth interviews and additional footage from today's show, visit our Facebook page or oklahomagrand.tv.